Hi, folks. I'm back. I survived a blue screen crash, which was exciting. I'm pleased to take the role of introducing the final session on doing more with less. Give me 1 second to call up my notes, which were here a second ago. Well, never mind. The point is, we have 3 papers, and they come from 3 different domains, and they use 3 different 3 different approaches. So we have all 3 approaches in all 3 domains, by which I mean we have Ben from MITRE, who will be using machine learning methods to help discuss how to improve audit case selection. We have Mary, who is from, I believe, who's an academic, I believe. I'm sorry, I don't have the introductory information right in front of me. Let me see if I can get it. Who will talk about experimental methods. And our final presenter is our in-house Clay from IRS, who will be talking about linear programming models that we can use to optimize resource allocation. So with that, take it away, Ben.
Thank you, Thomas. Let me see if I can, here we go. Today I'll be covering the topic of applying machine learning algorithms to correspondence audit case selection. In particular, I'll be going over algorithm selection, validation, and experimentation. Before I get started, I want to thank my co-authors, Lucia Leike and David Pinsky from the MITRE Corporation, as well as Alan Plumley from IRS RAS. Starting with motivation, why machine learning algorithms for correspondence audits. Definitions: correspondence audits are primarily conducted through mail, and each category of correspondence audit only will focus on a narrowly defined group of taxpayers and only examines a small number of line items. Traditional methods for selecting correspondence audits generally rely on subject matter expertise, so they generally rely on rules of thumb and only consider a few data points. In contrast to this, machine learning methods have a couple of advantages. First is that it can exploit many data points that wouldn't be considered otherwise, data points such as reporting history from past returns and other line items that aren't considered. And second, it can detect patterns among data points that may be non-obvious to subject matter expertise when predicting an outcome. Talking about outcomes, particularly with supervised learning, the outcomes I'll focus in my presentation are twofold. The first outcome is revenue, which is a continuous variable. Namely, I focus on the assessed revenue, which is the result of the audit after appeals. This is in contrast to collected revenue, which is what the IRS actually sees from the taxpayer after the audit. We choose to use assess because the availability of the data is much more recent than collected, whereas collected generally takes a couple more years after the audit is done to finalize. The second outcome I will consider is whether or not the return resulted in a no change or not. This is a binary variable and basically just asks the question, was the taxpayer compliant? Was the taxpayer found compliant? We define these as audits that result in $0 tax assessed or a false positive. Nobody wants no changes. They are not cost effective for the IRS, and they result in compliant taxpayers having to deal with an audit, which is taxpayer burden. So in a perfect world, avoiding no changes would result in higher revenue to the IRS, and that the resources it spends auditing these compliant taxpayers could be spent auditing non-compliant taxpayers, resulting in revenue-bearing audits. However, prediction is always imperfect, and trying to avoid no changes can result in missing out on higher revenue returns and vice versa. For example, consider more complex returns that might have more non-compliance issues. So if the IRS can prove those non-compliance issues, it would result in higher revenue. But because it's more complex, there's more uncertainty, and it can be harder to detect if the return is compliant or not before the audit. Data mining and machine learning is an active area of research in the tax domain. The one that comes to mind for the IRS is, of course, DIF scores, which tries to predict noncompliance on the full return and is generally applied to field audits. These don't translate to correspondence audits, which only can correspond to a limited number of line items and narrow slivers of the taxpayer population. Other tax bodies outside the IRS are also looking to apply machine learning. We point to studies done by the state of Minnesota and Texas, as well as Ireland. So for several years, MITRE and RAS have worked with campus exam to test the effectiveness of machine learning models in random control trials whereby the candidate population is split into two, and the machine learning algorithm is allowed to freely select from one half, and the status quo method is freely allowed to select from the other half. Namely, we focus on two different categories of audit, which I'll refer to as category 1 and 2. And while results varied year to year and the algorithm that was applied to them varied year to year, looking back, we generally see that the algorithms applied to category 1 resulted in lower no change rate while maintaining equal collected revenue. And the algorithm applied to category 2 resulted in higher revenue at the cost of a slightly higher no change rate. Learning, so take for example, tax year 2014, which was kind of like a hallmark year for these experiments. We see that around 15,000 audits were conducted for both the machine learning and the status quo group. And for category 2, around 21,500 audits were assigned to each group. Honing in on the takeaways, we see a lower no change rate for category 1 and a higher assessed and collected revenue for category 2 for the machine learning algorithm. While statistical testing is nuanced for this data based on how it was selected, we did do some basic non-parametric tests and found both of these results to be significant. So this leads us to the motivating question, kind of learning from past experiments, the initial experiments, and kind of seeing the nuances in operation. How can we move closer to the idealized scenario whereby no changes help increase overall revenue? And we also effectively also lowering the no change rate. So I'll be covering 3 strategies. While these strategies are not an exhaustive list of what we've considered in our group, they are theoretically different. So jumping right in, the first method I will present is called pairwise ranking. This is a learning to rank algorithm, and at a high level, audits can kind of be thought of as a learning to rank problem, in that given a pool of returns to consider for audit, the IRS would want to pick the highest level of noncompliance audit first, followed by the second, so on and so forth. And the way pairwise ranking goes about this problem is that it essentially trains a greater than or less than function on historical audit data. And during training, the objective is to minimize the number of inversions in ranking, which occurs when any given pair of results is in the wrong order. So to illustrate this, consider this very simplified example where you have a collection of circles. Gray circles are no changes, so $0, and green circles are changes with higher diameter circles corresponding to more non-compliant or more revenue-bearing audits. During training, we are trying to train a function which minimizes the instances whereby a no change may be ranked above a change, or a change with lower non-compliance is ranked above a change with higher non-compliance. Once this function is trained, we use it then to sort the entire new data set. And while we point out that in this example, and this is what we expect, that ranking won't be perfect, and that no changes will sometimes be ranked above changes, and changes of lower noncompliance will end up being ranked above changes with higher noncompliance, we do expect the resulting ranking to be better than random and to be somewhat of indicative of noncompliance. The second strategy I will cover is what we call two-stage regression. This is similar theoretically to a Tobit model. And it's a two-step process by which the first step is predicting if the return is a likely no change or not. We do this by using a binary classifier model such as logistic regression. And once we have the results of that, and we have, is this return a likely no change or not? We then assign a dollar value. So if it is a likely no change, we would assign dollar value 0 and not consider it because we don't expect to have, we expect this person to be compliant and it's not revenue bearing. Conversely, if it is an expected change, we would use a regression model that is trained only on changes and which then predicts the level of noncompliance. It's important to note that these two models are trained independently of one another and applied separately, which is in contrast to my third method, which we call penalized regression. As the name implies, this borrows from other penalized literature, such as lasso regression or ridge regression, whereby we take the output of the binary classifier model predicting the likelihood of no change, and we penalize the basic root mean squared error function when training on revenue to inherently bias the model such that it can balance kind of reducing error and the likelihood of being a no change. This results in one model that is applied at the end in contrast to the two models that is applied in two-stage that inherently balances the two objectives. So moving on to validation, when we are developing models, we want to make sure that we want to have some kind of sense that these models will generalize to populations that it has never seen before. So I'll be covering just 3 methods that we use. These methods are not exhaustive, but they go to tell different sides of the story. So before I get started with that, we use gradient boosted machines or GBMs with the XGBoost package. We use this for several reasons. First, notably, is that it is noted to have good performance outside of the box and has other nice features such as built-in feature selection, so it doesn't have to use all the variables that are fed into it, as well as being able to handle missing values well. And in our validation, we've noted that these tend to perform better than other machine learning algorithms such as support vector machines or SVMs. When we validate, we use out-of-time validation because when these models are applied, they are generally applied to audits from tax years that have never been seen before. So we make initial developmental models on older tax years, such as tax years 2012 and 2013, and then apply it to a tax year that the model was not trained on, such as 2016. After we are confident in the models and we're ready to apply them, we would then retrain the specification that we saw performed best on the most recent tax data, most recent audit data. Whenever we're validating, we always compare against the status quo method of prioritization. Again, that method that's based on kind of subject matter expertise and very few line items, as well as what we call perfect knowledge ranking. This ranking is the actual results of the audit. This is kind of what we're training our machine learning models on, and this is the best possible ranking a data set can give us. And we compare all other methods to this one in that it acts kind of as a ceiling of performance. So the first validation method I would present is what we call the Pareto frontier. This provides kind of a snapshot of how we might expect these methods to perform in operation. So we take the same holdout data set and we allow it to be re-ranked by each method. And we allow each method to pick the top 50% of the available inventory and calculate the no change rate as well as the assessed revenue. No change rate is plotted on the bottom and assessed revenue on the x-axis, and the assessed revenue is plotted on the y-axis. Because we want to minimize low change rate and maximize assessed revenue, the optimal region for this chart will be the top left. So some things to note, we see that two-stage performs the best at minimizing the no change rate while performing the worst at maximizing the revenue. Whereas pairwise and penalized regression both perform better than the status quo method of selection in our validation, with pairwise doing better at minimizing no change rate compared to penalized regression, and penalized regression doing better at maximizing revenue when compared to pairwise. The next method of validation I'll present is called the lift plot or the lift chart in other contexts. This takes the same holdout data set, but instead of calculating a snapshot, we observe it over the entire course of selection. So because we're examining over the entire course of selection and it's the same data set, we expect some peculiarities, namely that there are returns that methods wouldn't otherwise pick if exposed to a much wider pool of candidate returns that where resources would dictate that not everyone gets selected for audit. And this plays out in that we would expect that if exposed to its own pool, like in an operational experiment, that the intermediate trajectories would continue on. Another thing to note is that because they are all picking the same returns, they will, once all returns have been selected, all points will meet at the end of the metric. So in this case, we are plotting cumulative revenue across the entire kind of selection pool. Some things to note, because Perfect Knowledge knows the actual results of the audit, it will select no changes last, and because no changes don't add revenue to the cumulative revenue, this results in a horizontal line at the very end. We see vertical separation for penalized regression at all points. This means it's performing better at picking revenue varying audits, and we would expect, if exposed to its own candidate population, that this trajectory would continue. Pairwise is kind of neck and neck with status quo early on, but then around 10,000, it begins to separate, and we see a sharp edge for two-stage, and this is the point where two-stage starts to select its predicted no changes. The final plot I want to cover is the no change regression plot, and this is very similar to the lift plot, with the only difference in that instead of calculating cumulative revenue, it is calculating the no change rate at each point of selection. So similar to the Pareto frontier, we see that both pairwise and penalized regression show improvement in the no change rate over the status quo method of selection. Similar to the lift plot, we see the point where two-stage starts to select its predicted no changes in that sharp edge. And if exposed to its own candidate population, we would expect two-stage to continue with in this manner of having this very low no change rate. And again, similar to the perfect knowledge observation and the lift plot, we also see the point where perfect knowledge has to start picking no changes last, and that it has a perfect no change rate up until that point, and then it sharply increases to the no change rate of the data. Again, these are just this is just a snapshot of the validation we do. But it just gives an idea of how to tell, how to get the overall story from many different points of view. So wrapping things up, I want to make just 3 points. The first point I want to make is that while I primarily covered over the strategy used to balance these two objectives, it is only one consideration when developing machine learning models, and there are many more considerations that impact prediction performance. The ones that come to mind are quality data and features. This is kind of the garbage in, garbage out principle, and that you want good data that is accurate and representative, as well as features that correlate to the outcome that you're trying to predict. Another important consideration to note is what algorithm and package is being used. Earlier, I compared GBMs, and I said GBMs tend to work better than SVMs in our context. I'd be curious to kind of what the advancements in deep learning would do for this context, which we have yet to try. The second point I want to make is that decision makers have many more considerations for audit selection other than just maximizing revenue and reducing the no change rate. Considerations such as cost and the ability of the staff to handle the audits given to them. You don't want to give them more than they can chew. And to this point, it's important for analysts to kind of provide the options and to work with decision makers in developing models that meet mission objectives. And finally, machine learning will be the right tool in some situations, but not others. So when working with these decision makers, it's important to gauge where better prediction would make an impact versus just changing better business processes, as have been kind of discussed in earlier presentations. With that, I conclude my presentation. Here are some references that I used throughout the slides. Thank you for your time. Feel free to reach out to myself or any of my co-authors And with that, I would like to hand it off to Mary Marshall.
Okay. My name is Mary Marshall, and I'm an assistant professor of accounting at Louisiana Tech University. I am very excited to present the results of my research with Nina Collum, who's also an assistant professor here at Louisiana Tech, and with Susan Journey, an associate professor at Oklahoma City University. Before I begin, I'd like to echo earlier presenters and thank the conference organizers, especially the events team, for working so quickly on this virtual solution. We really appreciate the opportunity to present our work and get feedback. Our paper is titled Audit Productivity, Taxpayer Service, and Compliance. Can a Service Mindset Overcome a Dwindling Enforcement Budget? And if anyone has suggestions for making that title just a little bit longer, we're open to those. With that, I'll get started. I feel a bit silly discussing the need for improved enforcement outcomes after all of these presentations, but here we go. This project started during a conversation about a project that was presented last year by one of my other co-authors, Ethan Lamoth, and started discussing that largely experimental studies examining the effects of audits on behavior tend to focus on varying audit or penalty rates. But they usually assume that audits detect 100% of noncompliance. And even in times of surplus resources, if anyone knows what that looks like, 100% detection seems unlikely. So given the continuously declining resources that tax authorities face across jurisdictions, we think it's increasingly unlikely that they would have the resources or the tools, even with improving things technology-wise, to really achieve that. We know from recent studies that resources are rapidly declining, and I wish I could just insert the slides from our keynote showing the growing tax gap and the declining IRS budget. But instead I have a few cites from the National Taxpayer Advocate, where at the federal level we have 22% fewer IRS employees since 2010. We're dealing with antiquated systems and an increased workload, and these likely create overworked employees with low morale, which compounds on high workloads to create an issue with detection. So you could imagine that the feeling of the workload would continue to increase. With that in mind, the purpose of this study is to examine audit productivity, which we define as the amount of noncompliance that is detected by a tax authority during an investigation of the return. We have two research questions. The first is examining how declining audit productivity would influence subsequent compliance behavior after an audit, and we predict a negative impact on compliance. We think the taxpayers who experience an audit that is unable to detect all noncompliance will be less deterred from subsequent noncompliance than those who experience a fully productive audit. Our second and perhaps more interesting research question answers the question about how we resolve this situation. The ideal response is to allocate more resources, but we think it's prudent to investigate less costly alternatives that might be easier to implement. Excuse me. So prior research finds robust support for this conventional model of tax evasion, and I don't have control anymore. There we go. So the conventional model predicts that taxpayers will try to, there's a delay. The taxpayers will try to estimate the expected utility of evading, and they'll do that with several factors, and the two that we think are influenced by audit productivity are detection probability and audit penalty. And as this perceived detection probability goes down, if an audit doesn't detect all of the noncompliance, then that would become less influential to their decision to comply. Now, there is some tension to this hypothesis from the psychology literature that says that taxpayers are going to overcomply, and we don't really know why. But this study is restricted to only taxpayer participants who chose to evade, so that's a little less likely with this population. So we predict in H1 that taxpayers who experience partially productive audits are less likely to increase compliance in subsequent years than those who experience fully productive audits. So what do we do about it? There's a robust support for the effects of service efforts on taxpayer compliance. And there are a few examples that taxpayers are more likely to both file a return and to pay more of their liability when they do file if they receive service from the tax authority. And interestingly, research has found that the mere presence of a service, even if the taxpayer doesn't choose to access that service, can reduce negative reactions to being audited. We've also seen discussion of several great service efforts in the program today. So rather than proposing a new service initiative, our project examines whether taxpayers are less influenced by declining audit productivity if they're made aware of these service efforts. So you can see H2 that we predict is taxpayers who experience partially productive audits, that is less than 100% of non-compliance is detected, are more likely to increase compliance in subsequent years when they also experience increased service efforts. We believe that this could provide a relatively costless option for offsetting some of the behavioral effects of experiencing lower audit productivity. So how do we do it? Our experiment was administered to 595 US taxpayers on Amazon's Mechanical Turk platform. And we required taxpayers who wanted to participate to meet several criteria. They had to be at least 25 years old, had to have filed at least 2 tax returns in the past, and they were US citizens or residents. Participants were informed that it would be a simulated earnings task. And in that earnings task, we included a 30% tax rate, a 5 to 20% audit rate, and a 150% penalty rate. The audit rate is a range because, as I alluded to earlier, we measured compliance and then used only the participants who chose to report less than 100% of their earnings in this experiment. There were 271 who we categorized as evaders and selected for audit. The remaining were categorized as compliers, and they were redirected to a concurrently running study. So we weren't sure how many taxpayers we'd have, but we knew that somewhere between 5 and 20% of them would be audited. A key advantage of this experimental method was the ability to isolate the effect of these variables that are often confounded with other variables in the data. So we manipulated 2 variables, audit productivity, which we said was either 100% or fully productive, or 50% or partially productive. And we manipulated a message. So the message was either absent or it was present with one of 2 focuses. The first focus was on the Taxpayer Bill of Rights, and the second focus was on the IRS mission and its willingness to help taxpayers comply. I'll talk more about where those messages came from later in the presentation. So our taxpayer participants completed 3 experimental rounds, and it's kind of small, but you can see the flow of the experiment to the right edge of the slide. The first round was kind of a practice round. The second round was a categorization round where we split our compliers off to the concurrent study and then focused on our evaders. We assigned the evaders to 4 conditions. And then in round 2, when they reported their earnings, they were audited with full or partial productivity. And then in round 3, before they reported again, they either saw a message or did not. Our dependent variable is the change in compliance from round 2, which was before they were audited, to round 3, which was after the audit and, if applicable, viewing the message. So on this slide, you can see the amount reported by round and condition. Our dependent variable is on the furthest right column. And you can see that the full productivity with no message condition actually increased their compliance after experiencing the audit by 913. Now this 913 is out of the 10,000 experimental lira, which was the currency we used in the experiment. But in the partial productivity, compliance in the third round actually decreased by 1,300 lira. And when we compare those 2, we find that they are significantly different. So we find support for each one. And now to my favorite part of the paper, how do we fix it? So we piloted 6 different messages with a separate group of participants, and they rated whether they believed each of these 6 messages would increase compliance, and then they gave us some descriptors of those messages. We chose these 2 that are shown on the screen because they were rated most positively, but they were also described a little bit differently. And so we thought we could test two different attempts to send a message. The message on the left focuses on highlighting the mission of the IRS and its willingness to provide support. And we see it as an opportunity to let taxpayers know that the IRS didn't set the tax rates or the rules. They just enforce them, and they really are doing their best to help. The one on the right shows the IRS mission and then describes the Taxpayer Bill of Rights. And this one is more focused on making sure taxpayers are aware of their rights and that it isn't a unilateral relationship. So they're a little bit different, but they both highlight that the IRS is there for more than just to audit them and catch them in non-compliance. Interestingly, both messages produced very similar changes from round 2 to round 3 in compliance. And we didn't see many differences in the post-experimental questionnaires, so we just collapsed those for a single cell of message for analysis. Because we predict an ordinal interaction, we test stage 2 with contrast coding. And prior research suggests fully productive audits are likely to increase compliance for previously non-compliant taxpayers. So we assign codes of 1 to both fully productive conditions, which is here and here, or the 1 and the 3 on your screen. Our theory predicts that partially productive audits will increase compliance if there's no intervention, or decrease compliance if there's no intervention. And so we assign a code of -2.5, meaning that compliance will decrease in that condition to the partially productive audit without a message. And then we assign a code of 0.5 to the partially productive with a message to show that that might shift taxpayer focus to offset the effect when there is an intervention. Our hypotheses are supported because the contrast coefficient is significant and our residual between cells variance is insignificant. And you can see here that the plotted pattern of results matches what we predicted. I'm not sure if it's going to show up on every screen, but the light gray lines in this graph are our predicted pattern with those codes I described. And then the darker the black lines are the actual pattern of results in the experiment. But to dig down a little bit further, we also made specific comparisons, and you can see those in the table to the right. So each one predicts partially productive audits are less likely to increase compliance than fully productive audits. We compare cells 1 and 2 and see a significant difference. In fact, partially productive audits were significantly below 0, suggesting they actually increase non-compliance rather than improving compliance. H2 predicts a message will offset the effect of partially productive audits. And we find compliance after partially productive audits is significantly lower than all 3 other conditions. Now this one's especially interesting to me. Compliance of participants who experienced partially productive audits but also viewed a service message was not different than those who experienced fully productive audits. So in this context, the message actually offset that incentive to be further non-compliance in future rounds. I think that's a pretty interesting thing to think about because all we did was remind them of some service effort that the IRS is doing, and it actually offset the negative effect of declining productivity. Now, why did this happen? We asked several questions to better understand the reactions to audit productivity and to the messages, and a few really highlighted the effects. I'll focus on them for the remainder of the presentation. The first is really a manipulation check, but it helps make sure that our manipulation worked. And that's because it was a little bit subtle. We didn't say, hey, the auditor didn't find everything, because in that case, we'd keep looking, and eventually we would. If we were able to take the tax gap and figure out which portion of that gap applied to a specific taxpayer, it wouldn't be part of the tax gap anymore. Instead, we showed the results of the audit and indicated how much additional income the auditor determined should have been reported. And for those in the partially productive audits, that number was just smaller than what it really was omitted. When we asked participants whether the auditor did a good job identifying the income, those in the fully productive audits were significantly more likely to agree that the auditor did a good job finding omitted income. The second one looked at what could these messages have done. And we find that taxpayers were more focused on fulfilling their obligation to society as opposed to paying as little tax as possible when they were in a fully productive audit condition. Now this suggests that when they were in a partially productive audit condition, it actually made them feel like the tax system may have been more of a game and they were just trying to game the system more. But when they saw that the audit was fully effective and fully productive, they were able to focus more on fulfilling obligations to society. Now, some might say maybe that's because of the message, but those messages were evenly distributed across conditions. So this includes participants who did not view a message. We have a similar analysis for those viewing the service reminder messages. And we consider the results of one new question and then one question that also showed a significant effect in the previous slide. So we see taxpayers who viewed a service message were more likely to indicate that the IRS was focused on providing service rather than punishing criminals. And we measure this item with a Likert type scale where one anchor was providing service and the other was punishing criminals. So they looked at, the participants looked at it like a spectrum and then picked on a scale which one they thought was most descriptive of the IRS in this simulated task. And we conclude that the message made taxpayers more aware of the service efforts of the IRS because they were more likely to select an item closer to the anchor saying providing service, which is interesting because these are all evaders. These are all taxpayers who chose in round 1 and 2 to evade and report less, and then they were still influenced by somewhat of a psychological effect. In conclusion, we confirm that compliance declines in periods subsequent to a partially productive audit. Now, we acknowledge that some level of decreased audit productivity is likely regardless of whether resources are constrained, but we think this contributes to work examining the effects of declining resources on tax authority productivity. More importantly, we document a moderating effect of just a simple message on the negative impact of those partially productive audits. Although additional service is never a bad thing, we conclude that the IRS can improve compliance by highlighting existing efforts instead of having to find the resources and the staff to actually implement a new program. Of course, more work could certainly examine the effects of highlighting specific services for specific taxpayer groups or other more granular investigations. We don't go that far, but we do document that reminding taxpayers that the IRS isn't interested only in punishing them or in collecting taxes, but in helping them to comply fully. We think that can help prevent continued noncompliance in the future. Interestingly, both messages had similar effects on behavior. Now, the message focused on the mission and the Bill of Rights may be the easiest to implement, given that taxpayers already received the Bill of Rights upon selection for audit. So maybe making the Bill of Rights and or the mission more salient to all taxpayers upon filing a return could be effective as one part of a strategy to offset declining resources. Now, I'd be remiss if I didn't admit that we do have some limitations. We test the effect of a service message in one scenario, but we recognize that the tax system is much more complex than what we were able to control for in this one experiment. We are in no way suggesting that a message would offset completely unproductive audits. So there are likely boundary conditions to this, and if you had a 0% productive audit, we're not sure that a message would offset that effect. With that, I will hand over control to Clay Swanson.
All right, thank you. I am going to talk about the Program Assessment Model Optimizer, or PAM. It's a model that was developed by MITRE and currently is being transitioned to SPSC research. Can we go to the next slide, please? All right, and let's go to the next slide. All right, thank you. Okay, so suppose the Small Business Self-Employed Division of IRS is given authority to hire 100 or 200 or thousands or whatever number of new full-time equivalents, FTEs. How should SPSC management allocate the new FTEs across all the SPSC enforcement programs? And there's a lot of enforcement programs within SPC. There's examination functions, collection functions, sub-programs within exam and collection. So there's an infinite number of ways that the FTEs could be allocated. So this is the type of question PAM was designed to answer. How can SPSC optimally allocate new FTEs across the different enforcement programs? And we'll get into a little later what we're using to define optimal. So PAM is a data-driven model. It's transparent. All of the inputs and outputs are transparent, readily viewable. It's repeatable. It runs very quickly. We're able to run it hundreds or thousands of times, which we end up doing to account for different scenarios. And PAM accounts for SPSC as a whole. So it accounts for the interactions that take place between the different programs, which is something I'll address over and over. It's important because there's dependencies within the different programs. Adding FTEs to one program may produce additional work for other programs. So PAM needs to be able to know the additional work that's being created and allocate FTEs to other programs in order to handle that additional work. All right, go to the next slide. All right, technically speaking, PAM is a linear programming model. It's based on a multi-commodity network flow, and I'll have a diagram showing a subset of the flow a little later. It was created in R. There are some powerful R packages that can solve linear programming models. The framework of PAM can accommodate many different types of allocation measures. You can optimize on anything you have data for, basically. But currently, we are optimizing to maximize the collected enforcement tax revenue. So that's, I'll refer to that as revenue in future slides. So that's what we're trying to maximize. Slide. Okay, just quick background on setting up linear programming problems like this. Since we have many possible solutions, we need some method of defining what is the optimal solution. So we have an objective function, which is a function of our decision variables. And then we need to specify whether we're trying to maximize or minimize this objective function. And we also need to specify if there are any constraints or bounds, which are physical, financial, practical restrictions of any kind on our decision variables. And frequently we have bounds that restrict decision variables so they're non-negative, because often certain decision variables don't make sense as negative numbers. Slide. Okay, this is the current objective function for PAM. We've got an R term and an X term, and the R term represents revenue earned from working one tax module, and this is based on historical data. The X term represents the number of tax modules worked, and this is the decision variable. We have historical work rates that we can easily use to translate modules worked into FTEs. So we've got revenue earned per module times modules worked gives us revenue, and obviously this is what we're trying to maximize. Now, there are different types of tax modules, different types of non-compliance, different places in the enforcement system where revenue can be collected. So all of these conditions lead to different R terms, depending on what scenarios exist. So we have many different R terms, all calculated with historical data. So this is where the subscript and superscripts come in. So we've got many different revenue streams, and we just we aggregate them and try to maximize the sum of these different revenue streams. Slide. All right, here are a few of the constraints that we have defined. There are others, but I just listed a few. The first one, total new FTE are less than some total limit and max. So if we're given a number of new FTEs to allocate, this is the N max term. And so PAM starts at 0 and it can allocate FTEs up to the point of the N max term. So it's just an upper limit on the number of new FTEs to allocate. The second one, executed work is within the capacity of the workforce. This is an upper constraint on the amount of work that can be done. Again, historically calculated, we know the number of current FTE, we know the number of new FTE that we are trying to allocate. We have work rates for the different types of FTE, so we can calculate the number of modules that are possible to be worked. We can't work an unlimited number of modules. The third bullet here, started work must be completed. So this gets into the interaction. This basically means don't start work that you can't finish. If work is started in one program, we could end up producing work for a different program downstream. And especially phone calls, other types of taxpayer correspondence. We need to be able to ensure that there are FTE available to allocate to these downstream steps, so that we're able to finish the work that was started in a different step. Next slide, please. These are some of the bounds in PAM. The N term represents new FTE. So we can specify lower or upper bounds on certain types of FTE. For example, if we're trying to backfill, maybe there's some attrition, we can specify a minimum number of new FTE to be allocated. We could also specify an upper limit in case maybe it's not feasible to train a certain number of new FTE. So we can specify lower or upper bounds on the FTE allocated. We can also specify lower or upper bounds on work. And not listed here, but another bound that we've established are non-negative bounds on FTE allocations. So PAM doesn't take away FTE, it's only able to add FTE. Next slide. Okay, so this is a subset of the SBSC enforcement network. This represents how work travels through SBSC. The ovals represent steps. Steps are places where work is completed, not necessarily completed, but work is done. Steps are also places where revenue is earned. Also, steps are places where PAM is trying to allocate FTEs. The arrows between the steps represent paths through the system. Different types of work, different types of modules take different paths. And we call the different types of work commodities. We have historical data on the transition rates for different commodities between different steps. So we know how often a particular type of commodity moves between different steps. And sometimes it's 0. There's sometimes certain types of modules don't visit certain steps. So this is what PAM has access to in order to model the entire enforcement system. Next slide. So if we just pick one type of commodity, we can trace the logic that PAM uses. So for example, I'll just pick a particular type of commodity. For instance, individual returns with underreporting. We'll just assume that the red arrows and the red steps represent possible paths that 1040s with underreported income can take. And again, we know the transition rates between the different steps. So suppose that PAM decides to add one FTE to step A. So just a simple scenario, but there's a lot of calculations that result. For instance, how many new modules are started at step A due to the one FTE that was added there. So essentially, what is the work rate of the one FTE at step A? Also, how much additional revenue has been earned at step A, given that we've started new downstream steps from step A that you can see. How many additional modules travel to these downstream steps, such as step B1 and B2 and C1? How many phone calls are routed to B1 and B2 that we need to account for? Given that there's new work at these downstream steps, how many additional FTEs need to be added to these downstream steps in order to complete the work that was delivered to them? How much additional revenue is being collected at downstream steps due to the new work that's being routed here? So this is just from adding one FTE to one step to work on one type of module. And obviously there's many types of modules, many other steps. We could have added FTEs, and we could have added any number of FTEs as long as it's under the number we're constrained from allocating. So there's a lot of combinations, a lot of possible allocations, and there's a lot of considerations that go into identifying which is the optimal allocation. Next slide. All right, so when we run PAM, it's a 4-step process. The first step is running the linear program many times to create many solutions. And we run it many times because there is some uncertainty with some of our model inputs. For example, we can calculate how much revenue historically has been earned from working particular modules, but there are error bounds around our estimates. We can't assume that this historical number is going to continue exactly. So what we do is we randomly generate some of these inputs. All of the inputs actually are randomly generated within certain error bounds. And so we run the program repeatedly with slightly different model inputs each time, and so we end up with many different solutions. For example, we may run it 1,000 times and we would get 1,000 different solutions, each under slightly different conditions. We don't actually want to evaluate 1,000 different solutions. So in step 2, we cluster the solutions. Many of these solutions are likely going to be similar to each other. So we put similar solutions into clusters. And generally, we end up with 3 to 5 clusters. So similar solutions are averaged, and so we end up with 3 to 5 solutions instead of 1,000. In step 3, we take the clusters and we calculate the expected revenue for each of the solutions. So again, this is something it's repeated. With different randomly generated model inputs. And so the clusters are essentially competing with each other under different conditions to just determine which cluster produced the highest expected revenue under different conditions. Step 4 compiles all this data. It presents things like how many iterations did each cluster win? What was the average expected revenue for each cluster? Was there a certain cluster that performed well in certain scenarios and not so well in others? Was there high variability? So all this information is provided in tables and graphs for decision makers to look at. Next slide. All right, future enhancements. First, more distinction with module types. So PAM is linear. So the revenue earned per module is a constant. The R term that we looked at earlier is constant. So as far as PAM is concerned, for each type of return, it can continue earning the same revenue, whether it's the first module worked or the last module worked. It can continue to earn a constant revenue as it digs deeper and deeper into the pool of potential work. And in reality, this isn't the case. There's some decreasing marginal revenue that we need to account for. So what we've been doing is splitting the commodities or the module types into subgroups. For instance, we can split into small revenue, small expected revenue, medium, and high dollar subcommodities. And so we can kind of account for the fact that we can't continue to earn the exact same revenue as we dig deeper and deeper. Second point, workforce evolution. Currently, we don't account for the first point in that FTEs, more different FTE, different work rates, maybe different job duties, create more distinction between the FTEs. And finally, a future enhancement, exploring additional optimization measures on collected enforcement tax revenue, but we could optimize on other measures as long as we have available data. And with that, I will turn it over to Arnie.
Hello, can you hear me?
We can.
Okay, so I'm not sure, is the video working?
Not yet. No, just your sound.
I did start my video, okay. There we are. Okay, so hello everybody, you can get to my first slide. Oh, do I do it myself? Okay, well, I'll test out whether I have control. First of all, I'm gonna make an apology right up the front here. I got the date wrong, so you notice it's not the 28th, and hopefully before we post this, we can, for good, we can fix the date. And then I had the good sense on the next slide. What I want to do right away is, first of all, thank the organizers of this and for the giving me the honor and privilege to have read all of these papers, all interesting, important papers, and each answering the really core question, which was in the title: how can we be more? How can we do more with less? And I think every paper brought a lot of very important perspective into each of those from each of those different kinds of backgrounds. And the three ideas that were covered were better selection of cases for audit, new communications approaches during audits to improve compliance in general, and then more optimal allocation, all of which will answer that question about doing more with less, and all of which, by the way, has been part of what my work over many, many years in operations research has been focused on. Okay, do I really have control? So
I'll click the slides for you.
yeah, please. Next slide. Okay, so the first paper, which was delivered by Ben Howard, can machine learning improve correspondence audit case selection, considerations for algorithm selection, validation, and experimentation. This was a really interesting paper. I very much enjoyed reading it. And the problem goes back to a very old one. So selecting cases for audit it goes back in the IRS to certainly into the 60s, where the diff formula was first developed and was very innovative, frankly, at the time, and still amazingly does quite well. But as the developers or the authors of the paper pointed out, that correspondence audits are selected in a different way. I didn't know this prior to reading this paper. I wasn't sure how correspondence audits were selected, but the quote from the paper was that they're based on user-developed criteria or business rules developed to identify narrow taxpayer populations with suspected non-compliance. So basically, it's a little bit more on the judgment side as opposed to on a particular analytical approach. And I strongly believe that machine learning is a great way to go. And so the paper focuses on creating ranking and selection tools with solid theoretical foundations, showing evidence of improvement over the status quo, which we saw in the presentation, and I'll talk a little bit more about, but highlighting this important trade-off between maximizing revenue collection and lowering the number of no-change audits. But at this point, I'd like to make one comment about the, if you will, the equality of those two metrics. I strongly believe that the revenue part is very, very important, drives the tax gap challenges that Mr. Rosati explained so beautifully earlier, and is, in my view, the key goal that we should be focusing on. No change audits aren't all bad, in my view. Not all bad in this sense that if you don't have false positives, sometimes you can't improve prediction. And I actually had the great honor to work on RRP that was mentioned by Mr. Rosati, and that is one of the core ideas in that system. That is, we keep all the information about what predictions are made, and when there's a false positive, it informs future. So false positives aren't all bad. Plus the fact that you've heard a lot of people say about or talk about how important indirect effects are. There are still indirect effects associated with the no change audit as well. So they're not all bad, but obviously we don't want to make them bigger. We don't have more, but maybe having zero would cut off a little bit of information that's useful to have. Okay, so next slide. Next, okay. So the high-level summary, they described a research process that was in two parts. Initial research part demonstrated the potential benefit of using some of the machine learning tools. They mentioned that they used the support vector machines and gradient boosting, one for each of the different audit types. And part two focused, in my reading, on some very creative ranking tools underlying the process of selecting the correspondent audits. I think both of them showed promise, but part two was particularly useful in my view, and I'll point out why I thought that. Next slide. So in part one, there were two audit classes, taxpayers with Schedule C business expenses, and then taxpayer with Schedule A deductions. And they used, as was mentioned, they compared a machine learning method to a status quo method, the one we just described that was pretty much subjectively based. And I saw mixed results. That is, in some cases, a particular method, like for example, for audit class ones, the machine learning method was better than the status quo on no change, but worse on revenue dimensions, and vice versa with respect to the learning was not nearly as good on the revenue. And then with respect to the second audit class, I found they're not really consistently one way or the other. But I think there was, as was mentioned, enough benefit to go on to the next stage. Could you go to the next slide, please? Now, part two, I thought had really fascinating results. Focused on just one audit class, Schedule C, and they looked at three interesting ranking methods that were explained, and several innovative visualization tools, all of which I found very fascinating. And I want to just zero in on one of the findings that came out of the paper, which was when they looked at the, in particular related to the penalized regression, which Ben mentioned was similar to a lasso approach. I thought that was really interesting and potentially useful for this reason. That is, when you looked at the lift chart with compared cumulative counts against the cumulative revenue, penalized regression did better than the current status quo. Similarly, in the no change progression plot, the penalized regression had lower, so therefore was better, no change rate than the status quo. So in other words, uniformly on both metrics better than status quo. So it seemed to me that this opened up a very interesting potential benefit of this work, and one that in my view should definitely be pursued. The other thing let me see on the next, before I go on, I want to point out, in my opinion, that deciding between one machine learning method versus another isn't as much the key issue, at least in my mind, as whether we have the right features for prediction. And I want to point out that I didn't hear a lot of discussion of feature selection, or not feature selection, but feature engineering, feature development. And I think that one of the most critical things for future work in this area is creating new features that may in fact be more predictive than the features you have, rather than focus on what's the algorithm. Okay, so next slide, please. Overall, really good paper, very important work, well written and presented, and one that I hope the service will continue developing and following down some of the lines of successful outcomes that were mentioned earlier. Next slide, please. The second paper that was presented by Mary Marshall, the Audit, Productivity, Taxpayer Service, and Compliance: Can a Service Mindset Overcome a Dwindling Enforcement Budget? And by the way, your title's not really any longer than the others. But anyway, very good paper as well. I really enjoyed it. Learned a lot from it. The authors focus on core hypotheses, the two specific components, both focusing on the positive messaging about service aspects of the IRS during an audit and how they can improve downstream compliance, especially in the environment of reducing budgets and reducing resources. Using essentially a no-cost kind of idea like this is very important. in my view, and I think a very important finding of this work. And they also examined the issue of whether the audit that was limited in scope, that is less than 100% productive, was also benefited by the service information, and it turned out that it was. This is a good point for me to stop and talk about this notion of 100% productive versus 50% productive. It's hard to find a 100% productive audit because the current audit process, which is driven by the DIF formula and other exam plans, typically focus on just a few lines in the tax return. And so most operational audits, almost all of them, would be not 100% productive. It doesn't intend to be. It has a very clear and limited focus. And you heard earlier from Brian how, well, the other kind of audit that might be more expansive, close to 100%, would be those done for something like NRP, where the idea is to get a full picture of that taxpayer that's selected at random so that you can build better DIF scores, make better estimates for the tax cap, etc. And I didn't go back yet. So so the point is that it's hard to encounter 100% productive audit. And I'm not even sure, because I don't have data on what percent most operational audits are, but they may not even be 50%. So, but it is important to understand difference, and which your study had, that is thinking about the effectiveness of the audit. And by the way, that was mentioned or was part of the Matthias paper early on in today's, so I thought that was interesting, though you focused on the service side, which was very important. So to test these hypotheses, the authors created a research design using ideas from experimental economics as a guide. And I'll say a little bit more about that down the line. So next slide, please. So the two hypotheses, and because Mary did such a great job of explaining them, I'll try to do this quickly. Taxpayers who experience partially productive audits are less likely to increase compliance in subsequent years than those who experience fully productive. And that was very similar, again, to the Matthias hypothesis, one of his hypotheses. And confirmatory, you both had the same finding. And taxpayers who experience partially productive audits are more likely to increase compliance in subsequent years when they are exposed to the information about service efforts. Very, very interesting and important finding. And both of them essentially were able to be validated. But okay, so to test these hypotheses, you designed a testing protocol where you recruited participants using the Turk Prime. I was not, prior to reading the paper, all that familiar with this, but I learned it's a Google affiliated service that you pay them a minimal remuneration amount to get these participants. Again, more on that, because it's basically what it's a experimental design approach with recruited participants, and similar to the kinds of discussions that were mentioned earlier about this type of research. Then through that resource, you selecting only those that you described as, forgot the word you use now, but that were had compliance issues, 271 usable cases across this multi-dimensional design that allowed different audit productivity, different messaging, and then a series of activities in time. So that was the basic design. Could I get the next slide? And so the key metric for your testing the hypotheses was the measured compliance by the amount of experimental income truthfully reported at one stage, and then another stage after they had gotten were possibly exposed to a service message. The analysis was generally standard multivariate statistical analysis, but with, and that showed significant support for the hypothesis. But in addition, I found the use of contrast testing, something that came in from the accounting literature that allowed you to focus on the interactions of the respondent behaviors as, first of all, conforming to your, or supporting your hypotheses, but also fascinating, an area that I did not know about, and it seems like a really great tool for such research. Next slide. The key findings were that both hypotheses were supported, and this message, which I found to be very important: positive messaging about the service aspects of the IRS during audits can improve compliance in general, but also mitigate the negative impulses of continued non-compliance for taxpayers who experience less than fully productive audits. So that's a really important finding, and I think something that I hope the management within IRS thinks about as they develop examination methods. I also thought the use of the contrast testing was quite creative. Next slide. Now, I did have a couple of concerns, which I want to point out here. Frankly, I'm not completely comfortable, and I'm not sure I can be as articulate as Janet was earlier in my discomfort, but with the use of paid respondents obtained through an online source. I know this is the core of experimental economics thinking, and I know that I saw that you did a lot of screening protocols, evaluated demographic characteristics, you specifically mentioned higher education. But I also noticed that in the demographic comparisons, the group you had was actually different in both age and income from the general population. And I would have liked to have understood your population better. In other words, what was their historical tax compliance, if it was possible to create? And for essentially the same reasons that Janet described, was a little bit discomforted by the use of these people. Also, I found the sample size just a tad low, not really bad. The other studies were similar in size, but at least one or two of the strata were only in under 50 cases. So at the very least, it sort of calls out for some confirmatory research to bolster credibility. Next slide. Basically, another excellent paper. Focuses on doing more with less. In other words, using something that's almost free, a good positive service message, and something that I said earlier, I think IRS managers and designers of examination protocols should think hard about. Next slide. The last paper that was delivered by Clay Swanson, using the Internal Revenue Service Program Assessment Model Optimizer to inform resource allocation. So this is actually a subject that I'm quite interested in myself. I worked on a very early version of a model many years ago that didn't eventually turn into a model that's in use. But I believe that it's a very, very important activity. And we already learned about the trade-offs between increasing revenue and no change, and these are things that are all part of designing models of this type. A model uses mathematical optimization. There's also a very interesting that was described. I would use the term Monte Carlo simulation, where you selected different parameters, reran the model. Then you did use cluster analysis, another interesting idea to put them together into smaller groups. But it represents to me one way to think about what I'm going to talk about later, which is how do you manage uncertainty in models of this type? I think the uncertainty is huge, and to get a single factor, as we need in a mathematical programming models that are based developed to be deterministic, having certainty about the input parameters is a real challenge. So I have many questions, mostly about the actual operation of the model and also the form that I'll start talking about in the next slide. So, well, no, this one first. The real positives. Taking consideration of multi-stage characteristics in the model, described as commodity flow. Usually commodity flows, in my experience, are, okay, I need to go quickly. So I'll try to move quickly through through my next couple of slides, but at the very least, you looked at many characteristics, and that's important. Let's go to the next slide. I'll ask a few questions very quickly, and make a comment. I thought the focus on FTEs was probably not the conforming with what actually happens within the IRS, which is allocating dollars of budget. So notionally, it might make some sense. It's convenient, but FTEs are not fungible across program categories. So an RA FTE working a complex field audit, it's not really the same as a correspondence FTE. So maybe thinking about revenue per budgeted dollar makes a bit more sense in terms of getting the right, if you will, decision metrics. Another point that I make was I think many of the variables seem to be integer in my mind, like the number of modules worked, number of FTEs, and there wasn't any mention of whether these are integer variables, though a true commodity flow model could have integer solutions in certain cases, even if you don't make that assumption, but I didn't understand that you mentioned that. Next slide. Try to do these very fast. And I usually like to understand how the model's working, the number of variables, the number of constraints, solution approaches, the speed, where advanced methods used like decomposition, column generation, cutting planes. So those are the things that I feel I didn't hear about to make a good judgment about the model. The goals of the model were, how were they determined? Were different organizations part of this process? And were they part of setting the constraints? Because typically constraints change over time. And finally, and this is the most important one, getting a model like this to work involves socialization and acceptance. This is always the hardest part. And the key point here is readiness. That is, are the users of the model, the managers that will use this information, are they ready to have a model that, if you will, tells them how to allocate their budget? More likely, it's the beginning of a conversation. That is, maybe the results of the model is a starting point where people sit down and talk about it. And in terms of my experience in building such models, that buy-in, that readiness for an optimal solution is really critical. And so I think I'll go to the very last slide where I pretty much just summarize. Very interesting, important paper, very important work. And I very strongly support going forward with such models in the IRS. So again, thank you all for the hard work in your papers and the interesting ideas that you've presented.
Okay, I believe we have question and answer time now. Remind the audience to submit your questions through the Q&A box, not the chat box at the bottom of the screen. Okay, let me, I got some questions here, let's see. So Katie Wilson asks a question for Ben. What actions, if any, did you take to ensure the machine learning algorithms you employed didn't produce biased results, such as bias towards certain income categories, business sectors, ownership demographics, etc.?
Thank you. That's a great question, and pretty multifaceted because it involves kind of going, because it's a correspondence audit. There's many steps in the process. So first off, because correspondence audits are focusing on a narrowly defined taxpayer population, it's like working with campus exam to make sure that this kind of the definitions for this narrowly defined taxpayer population is more or less homogeneous. And then on the model side, we tend to do a lot of sensitivity analysis, whereby we take the model, take any variables that may be suspected to have maybe introducing bias out, and then train it without it, and then including them in, and kind of comparing, contrasting back and forth. But we do everything we can to reduce any kind of bias in that way. Thank you.
Okay, next, Mary Helen points out that the IRS's mission is to enforce the law with integrity and fairness to all, but the objective function of the PAM model is to maximize collected enforcement revenue. So is some concept of fairness incorporated as a constraint in the model, and or how is fairness taken into account in the process of using the model?
PAM is obviously optimizing to maximize revenue, but there are opportunities to add bounds to certain decision variables. For instance, if there is a certain minimum work or a certain minimum FTE that needs to be allocated, regardless of the revenue it brings in, those can easily be added as minimums or maximums for PAM to consider, and it basically forces PAM to allocate to those work streams or to those FTEs. So it's not entirely. There are ways to get around the revenue maximization.
Okay, thank you. I had a question for Mary, which was, what is the response in the experimental literature to the complaint that experiments performed on small dollar amounts may not produce the same results as if real dollars are on the table? I mean, plenty of people will be honest about $1, but not so honest about $1,000. How do you handle that?
Interestingly, these participants were the 271 of the group that evaded. So they knew that they would incur a penalty even on that dollar, and they weren't honest about the dollar. They forewent it to play the game and not comply. And so I think that there are some studies that have calibrated that payment amount and found that results generally aren't influenced by the amounts. And we're really looking at differences here. For me, I actually use this differential compensation just to get people to lie a little bit more so that I wouldn't need as many people to find enough evaders. So I don't think that it necessarily changes if we paid more. There is literature. I don't have any sites right now. If anyone wants them, they can ask. I'm happy to provide them. But there are some accounting studies that have actually, done $2 compared to $50 or $60, and they don't find that it has a different effect.
Amazing. Thank you. Interesting. I think we have time for one more question. Go ahead and type if you have one. I have one to fill the air. In the meanwhile, it's another one for Ben, which is, I still don't quite understand. I think Arnie's point relates to this. I don't quite understand why you treat the no change rate and dollars of revenue as separate objectives. I would have thought that dollars of revenue per dollar of enforcement activity expenditure is sort of the natural maximum, and that would save you the trouble of having two dimensions to think about. But there must be a reason why you keep those two dimensions separate.
Right, that's a great question. When looking at the distribution of audit results, you tend to see a bimodal distribution and that like when a revenue is non-compliant, it typically follows like a gamma-ish distribution, and you have like a large spike of zeros. So inherently it's bimodal, and we've seen greater fidelity, with the exception of the pairwise ranking, when we split it, like when we split kind of the root mean squared error and make it focus on kind of like minimizing kind of the gamma distribution. And that kind of brings us to a second kind of point to that, and that they're inherently asking different questions. The note, like when you're trying to predict no change in change, you're asking, is this taxpayer compliant or not? And when you're trying to predict revenue, you're kind of assuming non-compliance, and you're asking how much non-compliance is this return going towards. And what we see that as we move closer towards kind of perfect prediction, that kind of this kind of difference kind of settles out. And kind of going to kind of Arnie's point of better features, we do spend around like 60% of our time doing feature engineering, and our greatest kind of increase this year was when we had a little bit better features, and we did see kind of the methods kind of converge towards like kind of the more optimal situation.
Okay, thanks very much. I think that is the final question of the final session. And with that, I pass the baton back to Eric to wrap things up.
Okay, thank you, Tom. So I just wanted to acknowledge all the people who have contributed to this conference. It's been a great day, and thank you to the 184 people who are still here, and to others who were here earlier in the day. I want to thank my colleagues at the Internal Revenue Service, especially Alan Plumley, who I've worked with on these conferences for many years and who was honchoing it from the IRS end, and as usual, it's always been terrific to work with. I'd also like to thank Barry Johnson, who in his current role has been very supportive of this conference, and overall his work at SOI has been a great resource for the entire tax community. Thank you, Barry. Others on the IRS program committee were Quentin Anderson, Fran Capoletti, Brett Collins, Melissa Hayes, Alexis Kinnikin, Lindsay Schrock, Tom Hertz, Alcora Walden, and John Weaver. And they are the ones who are responsible for putting together this program, along with TPC's Rob McClelland. So thank you all. Having a virtual conference this year for the first time posed special challenges. Instead of hosting the conference this year, the Urban Institute hosted it virtually and handled the logistics. Ann Clevin of TPC coordinated from our end with IRS and did her usual great job in making sure all the pieces were in place. And I also want to especially thank our events team at Urban, Haley Romer, Ivy Hunter, and Nicholas Laughlin. It's because of them that everything went so smoothly with Zoom during the day today, and it really did go very smoothly. I want to thank all the presenters and discussants for a great program. And finally, I would like to encourage the members of the audience to fill out a survey of today's virtual conference. The survey is linked on the event page at our website. Again, thank you all very much. There's a chat here from me. From Urban Events that thanked me, and great job for everyone. So that's it. And it's always a little awkward to end a Zoom meeting, but I'm about to do that. So bye.